In this video, we're going to cover 6 basic rational expression examples, 6 problems you can see here. These problems do involve a lot of factoring. I'm not going to spend a lot of time talking about how to factor. If you need some additional support with that, go back in and watch the videos on factoring from earlier in the unit. All right, let's get started on the first one. We've got a single rational expression here, so we're just going to try and simplify this. To do so, we need to factor on the top and the bottom. Top is already factored, so we'll leave that alone. On the bottom, we can pull out a GCF. 12 and 36 both divisible by 12. Should be able to pull out an x as well. That's going to leave us with an x plus 3 on the bottom here. Now that both top and bottom are completely factored, we're going to look to see if we can simplify anything. So I'll look at this 36 over 12. 36 over 12 does simplify into 3 over 1. We'll look at the x cubed and the x. We'll be able to cancel that x in the bottom with one of the x's in the top. That's going to leave us with an x squared in the top. So in our final answer here, we will have a 3x squared in the top, and then a 1 times x plus 3 in the bottom. Second example. Again, just a single fraction, so we're going to go ahead and just simplify as much as possible, beginning by factoring in the top and bottom. X minus 2 doesn't factor, so we'll write it as its own factor. And we can factor on the bottom here. This is going to factor into x minus 2 times x minus 10. Now the numerator and denominator are completely factored. We can look to cancel and simplify. We will be canceling the x minus 2's in the top and bottom. Since there's nothing left on the top, we do need to leave a 1 up there. X minus 10 is the only factor remaining on the bottom, and that'll be our final answer. Next up, we are multiplying 2 fractions. So we need to start by factoring the numerator and denominator of each fraction. So the only thing that really factors here is the numerator of that first fraction. We can pull an 8n out of this. It's going to leave behind an n minus 1. 7n squared is factored. 1 obviously is factored. And this n minus 1 is also factored. Since we are multiplying, we can just combine these two things together into one big fraction, multiplying the tops and the bottoms. And then we'll look to see if there's anything we can simplify. The n minus 1s are going to cancel. We also have an n that we can cancel with one of the n's on the bottom, leaving us with just a single n on the bottom. Final answer here, we have an 8 times 1 on the top, which is just 8. We got a 7 times n on the bottom. And we're done. All right, this next problem is a division problem. And so to start out, we're going to go ahead and flip that second fraction and change this into a multiplication problem. So we're going to have a 7x cubed plus 21x squared on the top, x squared plus 11x plus 24 on the bottom. So we've just taken the reciprocal of that second fraction. This now becomes a multiplication problem. Next thing we're going to want to do is factor the numerators and denominators completely. X plus 8 is factored as far as it can be, as is 6x squared. We can pull a 7x squared out on the top here. That's going to leave behind an x plus 3. And our denominator is going to factor into x plus 3 times x plus 8. All right, now since everything's factored, we can go ahead and combine these together into a single large fraction, just multiplying the tops and the bottoms together, and then look to see what we can cancel in this fraction. So we've got x plus 8's top and bottom, x plus 3's top and bottom, x squared's to cancel completely. The only thing that's going to be left over at the end of the day here is a 7 in the numerator and a 6 in the denominator. Okay, we are adding 2 fractions together, so we're going to need to get a common denominator. Give myself a little bit of room here. We got a v minus 4. We got a v plus 6. Nothing factors in that denominator, so we'll just leave it. we're adding 4 over 5. Nothing factors obviously there either. So let's look at our denominators. I've got a v plus 6 here. Looking over at the other denominator, and notice that we are missing a 5, so I'm going to need to multiply by 5 top and bottom. Now it's got everything that the other denominator has. Looking at our second denominator, we've got a factor of 5 here, but it's missing a v plus 6. So I'll multiply a v plus 6 top and bottom. And now both denominators have the exact same factors. At this point, we can go ahead and combine these together into a single fraction with those two factors as the denominator. On the top, we're going to have, I'm going to go ahead and move the 5 out in front. V minus 4 plus 4 times v plus 6. Yeah, we need to try and factor the numerator, but before we can do that, we need to get rid of the parentheses and combine like terms. Let's distribute. Let's combine like terms. And we'll see if we can cancel anything. So the 9b plus 4 doesn't factor anymore, and that factor doesn't match anything in the denominator. So we're going to be stuck at this point. This will be our final answer. Okay, one last example here. Again, we've got a fraction that we're adding to something that's not a fraction. Now, I can always make this 5 look like a fraction by putting it 5 over 1. So let's go ahead and give ourselves a little bit of space here. So that denominator is factored for us. That was nice of them. Okay, so looking at the first denominator, it has a factor of 4x and x minus 4. The second one has a factor of just 1. Now, I could multiply in a 1 on the top and bottom, but it's not really necessary. That's not really going to change anything. So it has all the factors already that the second one has. The second one, however, is going to need to have some factors added in. It's going to need a 4 and an x and an x minus 4. And we need to multiply those into both the top and the bottom. All right, so now that we have a common denominator, we can go ahead and write this as a single fraction over that common denominator. Our numerators were 2 plus 5 times 4x. I'm going to go ahead and simplify that. I'll call that 20x. We can't do any canceling yet. We're going to need to distribute this 20x and then see if there's anything that we can combine, factor, and cancel after that. So distributing the 20x will get us 20x squared minus 80x. Looking to see if there's anything we can factor out on the top. There is a GCF of 2, so I will go ahead and pull a 2 out the front. That's going to leave us with 1 plus 10x squared minus 40x. And I want to try and factor that. That's kind of in a weird order, so I'm going to go ahead and rearrange those terms. We'll bring the 10x squared out in front and the 1 to the end. So 10x squared minus 40x, 10x squared minus 40x plus 1. And I actually already spent a little bit of time trying to factor that, and it did not factor any further. So let's see if we can reduce it all. We do have a 2 and a 4 that we should be able to reduce. That's going to turn into a 1 over 2. And that's all that's going to factor. So in the end, we are left with 10x squared minus 40x plus 1 on the top. On the bottom, we have a 2. We have an x, and we have an x minus 4.